Hi everyone. In today's video, we will be learning about Boolean algebra, which is a Contest 3 topic. So there's this really cool BrainPop video about logic gates, and it kind of introduces you to Boolean algebra. If you want to watch it, I'll have it linked in the description. Okay, so let's get started. First of all, what is Boolean algebra? Well, in order to know what Boolean algebra is, we first need to know what algebra is. Algebra is a type of math involving variables. Variables are letters like X, Y, Z, A, B, C, and they store an unknown value. Computers only use two numbers, true or false, 1 or 0, right? Like binary. And a Boolean is either true or false. So this means that Boolean algebra is a type of algebra that only involves two values. So what this means is that the variables can only hold either 1 or 0. Right. So there are three main Boolean algebra operators: and, or, and not. We can kind of get to know like what these do using sentences from our everyday lives. So for example, the sun is shining and it is raining. If both the sun is shining and it is raining, then the whole sentence is true. Or the whole sentence is 1, right? 1 is true. But if one or both is false, then the whole sentence, the whole statement is false. For example, the sun is shining and it is raining, right? This is true because the sun is shining and it is raining. But in this case, it would be false because the sun is shining, but it's not raining. And it would also be false in this case because the sun is not shining, even though it's raining, the sun is not shining. So the whole thing is false. Now we're on to or. So or basically means if one or both of the statements are true, then the whole statement is true. For example, 2 plus 3 equals 5, or 2 plus 3 is greater than 5. Now, we all know that 2 plus 3 is greater than 5, is not greater than 5, right? So 2 plus 3 is greater than 5 is false. But 2 plus 3 is equal to 5 is true. Therefore, the whole statement is true because at least one of them, which is 2 plus 3 equals 5, is true. Let's see. And we also have our operator not. Not reverses the value of things. So false becomes true, true becomes false. 0 becomes 1, 1 becomes 0. So not 2 plus 3 is greater than 5 is true because 2 plus 3 is greater than 5 is false. But if you do not on it, you reverse it, then it becomes true. All right. Now we have operators. Just like in regular algebra, regular math, Boolean algebra uses operators to write the expressions. So the plus sign represents or, the multiplication sign represents and, the tilde represents not. So for example, not, parentheses, A and B, parentheses, would be, can be written as tilde, parentheses, A, multiplication sign, B. And there's also an order of operations that you must do this Boolean algebra in. So parentheses are first, just like always, and then not. And it's because not only affects like the thing right next to it. And then you have and finally or. In junior divisions, actually, there is a XOR. So if you're in elementary, this doesn't apply to you, but for junior division, there's an operator called XOR. And the sign is this. Basically, for XOR, both they have to be different for XOR to be true. So XOR would go right above or and under and. Oh, sorry. XOR means different. Okay. So try these practice problems. You can pause the video, and when you are finished, I will go over the solutions. All right, so I'm going to assume that you are finished now, and we'll look at the solution. So the first one is the answer is 0. First step, you can rewrite this in words if you want, and then you do the things in the parentheses. So let's see. Yeah, so first you do not 0, and then you do 1 and 1, and then not 1 and 0. Okay. And for the second practice problem, this time we didn't rewrite it, but it still works. And the answer is also 0. Okay, so now on to truth tables. Truth tables are used in Boolean algebra, and basically they represent every possible outcome of an expression and every possible combination of the variables. So if there are two variables, there are only four possible combinations of 0 and 1. So this is a truth table for A and B. This is a truth table for A or B. You can see that they list out every possible combination of A and B and then the solutions. If you want to make the truth table for X or A, X or B, like this, then you'd say it'd be like this. Right? XOR, if they're different, it's true. This is the truth table for XOR. Okay. Truth tables can also be used to evaluate multi-step expressions. So for example, if we want to evaluate not parentheses A and B, we can first make a truth table for A and B over here, and simply take the not of these values. Right? All right. So try these practice problems. How many ordered pairs? Actually, no, I'll just say it. I'll just guide you through these. So these are some practice problems using this graph. How many ordered pairs make the last expression, A or not B, true? An ordered pair is a combination of A and B. It would be 3, right? Because there's 1, 2, 3 ones. Which ordered pair makes the first expression true? Which ordered pair makes A and B true? Ordered pair would be 1, 1, because A is 1, B is 1. All right, so now we're on to identities and simplification. So these are some identities of Boolean algebra. Now, I don't expect anybody to memorize these. My kind of recommendation would be to maybe print out a piece of paper with these identities and reference them. Okay. I would say the most important one is De Morgan's law. And all right, so most important one is De Morgan's law because it separates large like knots. You can see that not AB becomes not A or not B. Not A or B becomes not A and not B. This is De Morgan's law. You can see the truth table here if you want. This is kind of the proof. All right, so using that chart, try these practice problems. Okay, here is the answers. Okay. Okay. Now, equivalent expressions. Two expressions are equivalent if they have the same truth tables. For example, these two, well, this is just the same expression. Anyways, yeah, this is just the same expression written as words. But anyways, if the truth table or like if you simplify it and you get the same simplified solution, you could say, then the two expressions are equivalent. All right. Here are some practice problems. And in this case, you have to kind of see, is this true? Is this false? You have to like look at these equations and see if they're true or false. Okay. Yeah. All right. So that's it for today's video. Thank you for watching, and I'll see you next time.